Hello everybody. In this video, I'm going to explain important questions from 6th to 10th. Sixth question is, explain operators in C language. What is an operator? It's a symbol that tells the compiler to perform specific mathematical or a logical functions. We have a different type of operators in C programming language. Those are arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, and MISC operators. Let's see what are the arithmetic operators. So we know the basic symbols like addition, multiplication, subtraction, division, modulo division. All these comes under arithmetic operators. And we have two more arithmetic operators. Those are increment operator and decrement operator. All these are arithmetic operators. And the second type, relational operators. Relational operators are greater than, less than, greater than or is equal to, less than or is equal to, not equal to, double equal to. We know what is the equal to symbol. Equal to is assignment operator and double is equal to is a comparison operator. So all these are relational operators. Next, logical operators. So we have a logical operators, logical and, logical or, and logical not. These three are the logical operators. And next one, bitwise operators. So bitwise operators are single N and single R are the bitwise operators. What is the difference between logical operators and bitwise operators? Here we are using bitwise AND operator and or XOR, binary left shift, binary right shift, and one's complement of. These all are the bitwise operators. So I want to explain one program. So here I'm going to check A value 5, B value 10, C value is 6. So we know the program, biggest of three numbers program. In that case, we are going to write the condition if A greater than B. First, we have to check A with B and A with C, right? Then we are going to print A is big. Next, else if. In this case, we are going to check B with A and B with C. If the condition is true, we are going to print B is big. Else, directly we are going to print C is big. So it's a normal if loop, right? So here, instead of logical AND operator, we can directly use bitwise AND operator. We will get the correct answer. You can replace logical AND with a bitwise AND operator. The difference between logical AND a bitwise AND is, whenever you are going to use the logical AND operator, it will check both the condition, irrespective of the result of the first condition. It will check both the conditions. If you use a bitwise operator, first it will check the first condition. If it is true, then only it will check the second condition. If it is false, it will directly jump to the next condition, B greater than A. The difference between logical and a bitwise AND operator is, whenever you are using logical AND operator, irrespective of the result of the first condition, it will check the second condition, either true or a false. But whenever you are using bitwise AND operator, if the first condition is false, then it won't check the second condition. It will jump to the next loop. So that is a major difference between logical AND operator and bitwise AND operator. Because of this, the processor time complexity will reduce, right? Whenever you are using bitwise operator, execution time will decrease. That is a major difference between these two operators. Next one, assignment operator. So we have assignment operators like is equal to, plus is equal to, minus is equal to, multiplication is equal to, see, is equal to. Here, plus is equal to, add and assignment operator. We are going to call it as add and assignment operator. It adds the right operand to the left operand and assign to the result to the left operand. For example, a plus is equal to b. It's equivalent to a is equal to a plus b. This is subtract and, this is multiply and, this is divide and, it is modulo division, modulus and. So like that we have a different assignment operators like and is equal to, or is equal to, bitwise exclusive or. All these are assignment operators. Next, misc operators. Beside the operators, discuss like if you wanna check the size of operator. So there is a method called size of. It returns the size of the variable. So we can call it as a misc operator. And we have indirection symbol, indirection operator. In pointers, we use it to, it's an indirection operator, pointer to a variable. This is also a misc operator. All this comes under misc operators. And we have a one more misc operator, that is conditional expression. It is also misc operators. Arithmetic, relational, logical, bitwise, assignment operators, and misc operators. And the seventh question is, explain implicit and explicit type conversion with examples. Implicit type conversion. What is a type conversion? Type conversion is nothing but converting one data type into another, is known as typecasting. Using type conversion, we can provide or we can increase the size. For example, I declared here a value as integer, and here I'm storing a number, integer number 10 into the variable a. If I want to store a big number, integer can't support, right? In this case, I have to make it a long int. I want to convert a data type from integer to long. So type conversion is nothing but converting one data type to another data type. So there are two type of type conversions are available in C programming language. In that, first one is implicit type conversion. Implicit type conversion is also known as automatic type conversion done by a compiler. So we can, here is example program of implicit type conversion. Here I declared int a is equal to 10. And here I'm going to declare character b is equal to a. Whenever I'm going to execute this program, it will provide a memory location to the variable a, and the value is 10, and b, the value is a. Here I'm going to write a is equal to a plus b. A is equal to, what is a value? 10 plus, here I'm adding integer and a character. So here B implicitly converted into A. So here A value. So what is ASCII value of A? It's 97. So 97 plus 10, 107. A value updated to 107. Here B is implicitly converted into integer. Done by the compiler, right? Here I did not mention convert it into character or convert it into long kind of a thing. So here directly converted into integer type because I declared A as integer. And the next conversion is explicit type conversion. Explicit type conversion is nothing but converting lower data type to higher data type, higher data type to lower data type. It is also called as user defined data type. You can convert a lower data type to higher data type to lower data type. So the syntax, it's done by user, right? That means we have to do it. So we have to follow the syntax. Syntax is, we have to mention the type and the expression. So we have to write whatever the type you want to change it, you have to mention the type and you have to write the expression. So let me write the program here. Int A is equal to 10. Now, if you observe here, I'm going to convert my A value into, here I declared double B. Double B is equal to float of A plus 10.9. If you observe here, I declared A value 10. So here in the memory location, I have A value 10. So here I have a one more variable that is double with the name B. Here I'm converting manually, I'm converting A value into float. So A value will become 10.0. 10.0 plus 10.9. Both will add and it will store in the memory location B, 10.0 and 10.9. So 20.9. So here I'm doing it manually. If you observe here, type, I want to convert my expression A plus 10.9. This is my expression and the type is float. These two are the type conversion examples. Eighth question is, explain formatted and unformatted input and output with examples. Input means the data that we are providing to the program, and the output means to display the data on the screen. In C programming language, we have a standard library that allows input and output in a program. We are using stdio.h. Using the standard library, we can give the input data to the computer and it will print the output on the screen. We have two types of input output functions. In that, first one is formatted input output functions and unformatted input output functions. First one is formatted input output function and unformatted input output functions. Printf, scanf are the examples of formatted input output functions. And getch, getchar, gets, puts, putchar are the examples of unformatted input output functions. Printf, scanf. So these are from standard library stdio.h. stdio.h contains the definition of the functions printf and scanf, which are used to display output and on the screen and take the input from the user respectively. If you want to read anything, we are going to use scanf. If you want to print anything, we are going to use printf. Format can be simple, constant string, but you have to specify format specifier. If you are going to read integer, you have to mention %d. If you want to read float, you have to give %f. If it is a character, you have to give %c. If it is a string, you have to give %s to read the string values, integer values, characters, right? There are many other formatted options available which can be used based upon the requirements. And getChar, putChar functions. GetChar function reads a character from the terminal and returns it's an integer. This function reads only single character at a time. And the putChar function displays the character passed it into on the screen and returns the same character. And it will also display only a single character at a time. GetS. GetS function reads a line from the buffer pointed to the pointer like a standard input. Whenever you want to read a particular line from the terminal, we have to use getS. Here also we are using scanf to read the information from the user. Here we are using getS to read the information from the user. But what is the difference between scanf and getF? The main difference between these two functions, scanf stops reading character when it encounters a space. For example, if I give ABC, CMN, it will stop because here I mentioned a space. But getS reads a space as a character too. getS will read the complete line, including this space. It will treat this space as a character. Example. For example, if you entered addition of two numbers, scanf will read only addition. It will read and it will store in a particular variable because here it's a space, right? But getS will read the complete line. That is the major difference between scanf and getS. And ninth question is, write a C program to read a floating point number, display the rightmost digit of the integral part of the number. So first we have to write the program to read a float number. So here I am going to read the float number. First I have to declare a float value, float. Here I am giving float value, variable name is A. Printf. I'm going to print a message on the screen. Enter any float value. So by reading this message, user will enter a float value, right? Now I'm going to read the float value from the user. So here I'm going to use a format specifier F because it is a float value, and I'm going to assign the value entered by the user to the variable A. So let me execute it. Enter any float value 12.6. So enter, because I'm not printing that value. So here I'm going to print my float value, printf. $12.6. So it's displaying some, because here I used FD, right, instead of F, because I'm going to read float value. So 12.6. So I got the A value 12.6. Write a C program to read a floating point number. Till here I'm done. Display the rightmost digit of the integral part of the number. Display the rightmost digit of the integral part of the number. If you observe here, integral part of this float value is 12, right? It's a float number, 12.6. What is the integral part of the number? Is 12. I have to print the rightmost number. It's nothing but expecting output is 2. Rightmost number, right value is 2. So I have to finish the program. Till here, I'm able to read the float number from the user. But now I have to convert this program into, I have to read the integral part of the float number and print the rightmost number. So I need few more. Here I'm not going to use. First, I'm reading the integer float number from the user. First, I have to convert it into integral number. So here I'm taking one integer number, int I is equal to, I'm going to assign the A value. Here I'm going to assign float number to an integer number. Now convert it into integral part. Now I have to read the rightmost number. So rightmost number. So here I declared one variable with the name rightmost number. So whenever I'm going to use modulo division by 10, so here I modulo division by 10, I'll get the remainder, right? So remainder is nothing but the rightmost number. So here I'm going to print rightmost number. So let me explain this program. Here my program execution will always start from main method. So after main method, I have the initialization part. Here I'm going to initialize the value A. It's a float number. Here in this next line, I'm going to ask the user to enter any float value and I'm going to assign that to variable A. For example, here I entered a float value 121.6067. So here I'm going to assign the same number to the variable A. That means I have to store here I'm going to store 121.6067. The next I created one more memory location to the variable I. And if you observe here, I'm going to assign my A value to variable I. So if you observe here, it is a float value and here I declared integer I, so that I can read only integer part of the number. So I can store only 121 in I, not the entire number. Here I'm doing the typecasting, converting float number to integer. So automatic typecasting. In the next line, I'm going to create one more variable with the name rightmost number. So here my variable name is rightmost number. Here I'm performing I. What is the I value? That is 121. 121 modulo division by 10. 12. So here I'm going to get the remainder 1. Whenever I'm going to use modulo division, I have to read the remainder. So I'm going to assign this 1 to the rightmost number. So I'm storing this 1 and I'm going to print f percentile d, because the rightmost, I'm going to read the rightmost number from the memory. So rightmost number is an integer. That's why here I mentioned percentile d, and I'm going to print this 1. That is the rightmost number, right? I got the correct output. I'm able to display the rightmost digit of the integral part of the given number. So this is the given number, this is the integral part of the number, and the rightmost number is 1. I got that correct output. So let me execute the program. 121 point, because I have to give the float number. So rightmost value is 1. So we can also add a message here like rightmost number is 121. Okay, let me give 123.678. So rightmost number is 6. So here is the program.